For the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on fluid statics. In our previous lessons, we often used water or another liquid to test our principles of fluid statics. But it is important to remember that a gas can also be a fluid. Today, we will study atmospheric pressure, and we will look at how to measure the pressure created by gases in a confined area. Let us begin. Earlier in this unit, students, you were introduced to some terms used in the study of pressure. Let us review these definitions. Pressure is defined as the amount of force acting on a unit of area. Atmospheric pressure is the pressure exerted by weight of air against a surface. Whether or not you have ever realized it, you experience atmospheric pressure every day when you go about your daily business. Students, you might know that weather forecasters use atmospheric pressure to predict weather changes. They use an instrument called a barometer. The most common barometers use mercury to demonstrate pressure because mercury is a responsive liquid that is stable under pressure. Mercury barometers consist of a reservoir and a sealed tube that rises up out of the center of the reservoir. When atmospheric pressure is high, it presses down on the mercury in the reservoir, forcing the mercury up into the tube. When atmospheric pressure is low, it allows mercury to flow out of the tube and back into the reservoir. Atmospheric pressure rises when air moves across large cool masses, such as cool water or land. This is an indication that cooler weather is coming. Atmospheric pressure falls when air moves across large warm masses, such as warm water or land. This is an indication that warmer temperatures, storm, and rains are coming. Students, if you know that cooler weather is coming, how do you think the mercury level in a barometer will react?
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello, students. Cooler weather indicates a rise in atmospheric pressure. This increase in pressure will push down on the mercury in the reservoir and force the mercury up into the tube. The barometer, therefore, will register a higher reading than it previously did. Another instrument used to measure pressure is a manometer. A manometer measures the difference in air or liquid pressure by comparing it to an outside source, usually the Earth's atmosphere. In a manometer, one end of a U-tube is filled with the gas to be measured, and the other end is left open for a natural pressure level. Depending on the strength of the gas, the mercury at the bottom of the U-tube will move up one side or the other. If the gas is heavier than the air, it will push the mercury in the sealed end below the equal point. Students, have you ever seen someone cook with a pressure cooker? A pressure cooker is one of the fastest ways to cook food. Because the lid of a pressure cooker is sealed, it does not allow any steam that is produced by boiling water to escape. This builds pressure inside the pot. The temperature and pressure have a direct proportional relationship. As one increases, so does the other. As a result, a pressure cooker is able to raise the internal boiling point above 212 degrees Fahrenheit. Once the internal pressure reaches the desired level above air pressure, a relief valve on the top of the cooker must be opened in order to prevent the pressure from building any further. Students, you have seen how pressure can be used to measure and move gases and liquids in various instruments and tools. But did you know that your body is a walking, talking, breathing example of air pressure at work? Every day, we breathe about 20,000 times. And most of the time, we do not even think about it. Every breath that you take in and expel out relies on air pressure. Teacher, please separate the class into groups of 3 or 4 students. Using the terms we have been studying, including atmospheric pressure and high and low pressure, can you explain how respiration works? Please take a few minutes, students, to discuss your ideas. You may begin now.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Welcome back, students. I am sure that your groups generated many good ideas. Let us see if you were correct. First of all, we know that gas always flows from high pressure to low. When we exhale, our lungs contain a higher air pressure than is found in the air around us. Our diaphragm moves upward, making the chest cavity smaller and increasing the pressure of the air in our lungs. This forces the air up and out of the nose and mouth. When we breathe in, the diaphragm moves downward, and the rib muscles pull the ribs upward and outward. This enlarges the chest cavity and reduces the air pressure in the lungs, so air from the higher atmospheric pressure is pulled in through the nose and mouth. Students, today you have learned how atmospheric pressure can be measured, and you have studied many different examples of pressure created by contained gases. You have even learned how air pressure and breathing are related. In our next lesson, we will look at surface tension and surface energy. Until next time, thank you, teacher. Thank you, students.